Hi, my name is Prasad. My emerging technology topic is brain control computers. Let us see the overview and background of brain control computers. So, what exactly is the brain control computing is? Are you very tired of using your laptop, keyboard and mouse to control your computers? So if that is the case, then what is the next step? When you think, and if it happens, how interesting it will be. As simple as that is the brain control computing. When you think your laptop screen has to be changed, or it has to move on to something, or if you want to listen to your favorite music, if you want to browse the internet, when you think and if it happens, then imagine how it will be. So that is brain control computing. If you think something, that happens automatically. So that is how the brain control computing works. So let us see the organization that are related to the BCI. BCI is nothing but the brain control interface. The Plinon, Neurolex, Ripple, BlackRock Microsystem and TDE are the organizations that are working on the BCI. So how long it will take for the BCI to come into existence? It might take 10 to 15 years from now, or even it might take more. So there are a few kind of gadgets, electronic gadgets that has been implemented using the BCI technology, and one among is the EEG headset. So what it does, it automatically chooses the music when you think. But the problem with the headset is the quality wise it is very poor and it is very low. And in this hypercycle graph, you are able to see an orange block which identifies the brain control interface with a triangular symbol. So what does the triangular symbol indicates? It says it might take 10 years from now or even more to come into existence. So this is in an innovation stage, and think once it comes into existence how you can play around with your gadgets. Let us see how the BCI works. Before knowing how the BCI works, we are supposed to know what happens inside our brain. So our brain is filled fully with our neurons. So these neurons are interconnected to each other. When you wanted to move, or when you wanted to walk or lift your hand, these neurons or your brain generates some electrical signals. These signals are sent using the neurons, and so these electrical signals are traveled using the neurons, and so you are able to lift your hands. And how this is BCI is interlinked to these electrical impulses is a electrode will be fitted inside the brain. So the electrical signal or the pulse which is generated by your brain will be captured by these electrodes, and it will be sent to your mouse or your monitors or screen. So whenever you wanted to change the mouse, whenever you wanted to click something, or you wanted to change your screen, or you wanted to select some favorite music, these signals are converted into electrical these are converted into electrical signals, and it travels using the electrodes, and it reaches the input devices like electronic gadgets. So these gadgets receive the electronic signal, and it processes it, and it acts according to your brain signal. So that is how the BCI works. And let us see a video that is related to the BCI.
3 words: telekinetic cursor control. Is your brain ready? It's a fact that our technology comes with the residue of our ancestors. Like the computer keyboard resembles a typewriter. Why? I mean, why does it look like a mixed up game of Boggle whenever I want to interact with my computer? Or the computer mouse. I'm dragging and dropping icons. That's like poking papers with a stick on a real desk. There is a revolution coming in human-computer interactions, and it's all going to amaze you. We don't need a keyboard. We don't need a mouse. All we need to do is enter the digital world directly. The computer mouse can move in only 2 dimensions, and it has just one basic action, the click. Our hands are at least 3 times better. I mean, they're 3-dimensional. They move in 3 axes. That's 6 degrees of freedom. So we just keep track of all 6 using something like wired up data gloves or 3D stereoscopic cameras. And then you add voice command, you've got a new command pathway. We already have voice recognition software that can understand us about as well as a wiretap operator. So the next step is to add natural language processing, which means that it won't just understand pre-programmed keywords, but everyday talk. All right, bring me back. Whew. Tingles. Look, gesture and voice control have already reached the level where consumers have access to them, which you probably know if you've played with an Xbox Connect or ever tried to chat up a lady named Siri. The goal is to remove as many barriers between us and data as possible so that the interaction is natural. But I can think of something that's even faster than voice and gesture. Can you take a guess? I'm talking about the brain. Alright, get this. Scientists are making batches of cyber monkeys capable of controlling computers with their brains. There, I said it. Now, this isn't just some sort of supervillain plan to take over the world. In fact, it's nothing like that. It's actually really cool. Not only do we get a real understanding of the cerebral cortex of your average rhesus monkey, we also have learned how to create a translation algorithm so that they could control a cursor on a screen with their minds. And for humans, well, we've created neural implants that allow quadriplegics to do things that they haven't been able to do in years. By moving a robotic arm with their mind, they can do things like feed themselves, so that's pretty awesome. So if we can use our minds to move a cursor or a robotic arm, what happens in the future? Maybe we can use our minds to make a self-portrait, or we can type out a fan mail to Ray Kurzweil, or we can create a playlist just by thinking about it. So much punk. This is what I'm talking about, removing those barriers, making it more natural to interact with our technology, making it organic so it's just the same as if you're cleaning a kitchen counter. Well, now you're cleaning your hard drive. Or throwing a ball. Well, now you're designing the next Hadron Collider. The possibilities are literally limitless. We can do anything we can put our minds to. That said, I'm out.
So that is what the brain control computing is. I think you all enjoyed the video, and let us see what is the risk that is associated to the BCI. So how your device and your brain is being communicated. It is using the brain waves. So let us imagine a third person is able to hack using your brain signals. So what happens? He will be able to steal all your electronic data. Sorry, he may be even get your passwords, or he may get access to your banking accounts, and he may know your secrets, and he may do some transaction with your banking account. So how serious is that? So these are the risks that are associated with the BCI, and let us discuss the cost that is related to the BCIs. So the BCIs are being invented in many fields. It might be medicine, it might be technology. So it depends on the technology it is being implemented. The cost depends on the technology or the gadget it is being invented. So let us consider the headset. So a BCI headset, it ranges from it starts from $1,000, and it keeps going. And when it is integrated to the sensors, the cost will go really very high. So this is the risk and the cost that is associated to the BCI. So let us see what are the challenges that are in the BCI. Training the user according to the device is really very toughest part in this. And the other one is understanding your brain's functions and other things are also really tough. And designing an algorithm according to your brain functions is also a toughest job. And the interaction with your tissues and the electrode, feeding an electrode inside your brain, it really takes manual work, and that is the toughest part. And the information transfer rate between your devices and your brain. So if the data size is really huge, imagine the transfer rate, how the transfer rate should be. So it depends on the transfer rate also. So this is also a biggest challenge, and noise plays a huge role in it. And these are the things that are related to the challenges in the BCI. So let us see what are the opportunities with the BCI. It makes the impaired person to move their limbs and their hand, and it makes the impaired person to visually transmit the picture to the screen, and it makes the deaf people to listen to the music also, and for the gaming people it makes them to play the game virtually. So these are the opportunities that are related with the BCI, and let us see the testing part. And currently the BCA is being tested only in the laboratory with the human brains, and mainly it is tested with the monkey brains. So there is no much related things to the testing part. And these are the references I looked through to get all these materials. And thank you for listening to the video. Thank you once again. Bye bye.